Okay, we talk about the example of organization of the air traffic about related to our packet the behavior. Actually, you know, is like an airplane is an end-to-end transfer of the person, the plus packet, right? When you travel out to America from Taiwan to America, actually it's plus to packet, and plus to the package. So how could you define and discuss the system of airline travel? Okay, actually it's a series of steps involving a lot of service. So it's about service, right? First, you need the ticket, right? The ticket you have to purchase. Then also check the package. Then the gate, you need to go to the gate. Which gate? The boarding, right? Then you need a load. And then along the way, the takeoff, the airplane takeoff. The airplane routing, right? Routing to from the Taipei to Hong Kong, then to transfer to the Los Angeles to America. So actually, the airplane routing is routing to America. Then along the way landing, right? It's landing to, for example, it's landing to the California, San Francisco. And also, the airport, you need a gate. You need to output the gate, right? And unload your package and unload and the gate of the airplane. And also, you have the ticket, the client package. And if the ticket, then you also have some complaint, right? So totally, we can internet. The protocol state, the layer by layer, actually is almost the same. You can see it's like the application layer. The application layer support the network applications like the HTTP, IMAP, and SMTP support the email, and somehow it's a domain name system, right? It's for the domain name change to the IP system. Is in the application layer. Also, we can see in transport layer. The transport layer is processing the data transfer, the TCP or UDP, right? The TCP we call the email non-real-time service. The UDP we call the real-time service, like the streaming or on the video conference. And the TCP we sometimes reliable packet data, and the UDP is unreliable packet data. It's in the transport layer. And also in network layer. Network layer is the routing of the datagram from the source to destination, which means based on the IP routing, right? The IP routing the protocol. The IP, which means the source, from the source to the destination. And also the IP, then we definition link layer. The link layer actually is data transfer between the neighboring network element. Actually, it's over physical layer. It's data transfer. The data transfer between the nearby and between the neighboring network, like the Ethernet, right? Ethernet protocol. And somehow we all use Wi-Fi 802.11, and also PPP protocol. And also the physical layer based on the bit on the Y. Okay. So the service, the layering and the encapsulation is based on this architecture from the source to the destination. It's the peer-to-peer, application to application, transport to transport, network to network, link to link, and the physical to link. Physical is also from the source to destination. So in application, the application is exchange message. The exchange message to implement some application service using the service of transport layer, right? So it's based on the service, and we send the message on application layer. But the message here, we need to add a header, for example, header HT in the list message of the header. When we transfer to the transport layer from the application layer, we need to add a header to the message down to transport layer. Then transport layer protocol transfer the M we call the message. Right now, for example, it's a reliable from the one process to the other, using the service of a neighbor layer. Then transport layer, the protocol encapsulates application layer message. That is called the encapsulate layer message. We call the header. And the M with the transport layer to layer, the header HT. And then to create a transport layer the segment. Okay, that is one, the transport layer segment. Then HT used by the transport layer protocol to implement its service in the transport layer from the application layer of the message. Then also is the same behavior. We also need a neighbor header. So when we down to the neighbor layer, so we have to add a neighbor header. Neighbor layer protocol transfer the transport layer segment, right? The transport layer segment here. And the transport layer segment is down to neighbor layer. And the H and T from the host to the other, using a link layer service. Then network layer protocol encapsulates the transport layer segment, right? The HT and M with neighbor layer HN create a new neighbor layer, the data grid, like this one. New neighbor layer data grid. And HN used by the neighbor layer protocol using implement this service in neighbor layer. So the neighbor layer encapsulates the transport layer segment. Is capture the transport layer segment in neighbor layer and HN. Then also the down to the link layer. The down to the link layer is also the here, right? Here down to the link layer, and add to the header of the HL, the header. The link layer protocol transfer the data grid from HN and HT and then the message application layer here, the data grid, from the host here to the neighboring the host using the neighbor layer service, so that peer-to-peer. Actually, the neighbor layer, the protocol, encapsulate the neighbor layer, the data grid, the HN, right? HT and HM, the encapture the neighbor layer, the data grid. And with the link layer header, HL, create a link layer frame. So it's called a link layer frame. Create a new link layer frame from the neighbor layer, the data grid, with the new header, HL. Encapsulate neighbor layer data grid in the link layer. So when the message is here, the segment here, and the data grid in neighbor layer, and the frame in link layer. So we call the definition, the message we call the application. The segment we call the transfer, the TCP or UDP. The link layer we call the data grid definition, and the link layer we call the frame. Then with each layer, from the message we add a header encapsulate HT, and the datagram is segment from here, right? Become the IP datagram, the HN header, and then to the link layer to the frame. The datagram here on IP layer, and add the header HL in link. So the message actually is like the airplane from the physical layer, right? Sent to the other host. So we need to remove each header. For example, from physical layer, the mid here, the total package here, but we need to remove the HL to this datagram, right? From the frame to datagram. Then to the transport layer, remove this HN. Then to the M to message, remove the HT. Then we can read this message from application layer. So the behavior is like this one. So encapsulation, the end-to-end view. Okay? The message in application layer from the source to the destination go down to the transport layer, network layer, link layer, physical layer, and actually it's not the end-to-end then goes through the link layer, the physical layer, like the link layer switch, and go to the router, which means the IP router is a network layer. Need to understand the source and the destination address. Go to the network address layer, and from this go to this destination. From the physical link and the network and the transport and the application, and get to this message. So you can see the message here. The message from the application layer to the transport layer. Then go change to the segment, right? With a new header, the segment. Then we go to the network layer. Then go to the IP network. It changed to the sec datagram, and it's the IP. And the network layer is header, and one header, HN. Then we go to the frame. We also need a link layer. And the link layer, we call this frame, right? And then add one header, the link layer header, and we call this frame. And go to the physical layer, and go through link layer, and go to the router. Because the link layer we just passed here, direct pass. And the router we need to the IP address from the IP routing table. So the message here, is the link layer header here, because it's a link, right? Link layer header. Then we need to encapsulate because IP layer is IP network, right? So change to this HN header for the IP. Then go to the network layer, then transfer to this one source and destination, the IP. Understand the routing table, and then go to the link. Also, combine the link layer HL, because it's a link layer transfer, right? So link layer from here to here, and then go to here. We also add the link layer header. Then go to the physical layer, the link layer transfer to the other MAC address of this computer. So here you can see the total package here, link layer, the IP header, and the transport layer header and the message, right? But on this link layer, transfer from this one source to this destination, from this link layer to this link layer. Okay? So when we go to the link layer, want to go to the network layer, we should be remove the header of the link layer header. Then the HN header, the network IP layer, right? Then remove the network layer of the header. Then the HT transport layer header and the message. Then go to the application. What happened? Return to the message. Remove the transport layer of the header. So then the destination, the user can understand this message from here to here about the end-to-end view, encapsulation, this message. So totally the network behavior, we can check a Wireshark. You can use the field download this tool on the internet. You just key the Wireshark. You can check this behavior. You can practice in the Wireshark. It's free. It's free. So Wireshark actually, you can see the packet analysis and packet capture, and copy all the internet friends, the send to and the receiver. We can check the link layer Ethernet, in the IP or the TCP or UDP based on the different OS. For example, and what kind of application you use, like the www browser or the email client, and go to the transport layer. We can use the TCP or UDP on over the IP and the link layer Ethernet and the physical from this computer to this router or ADSL. So basically, we can talk about this application overview. This way, say the principle of the network, the application, and about the web and HTTP, and somehow the email, SMTP, IMAP, and the domain name server, DNS, and the P2P application, and about the video streaming and the content distribution and network, and somehow about the circuit, programming about UDP and the TCP. So the application layer overview, our goal is conceptual and implement the exception of application layer of the protocol. We will discuss about transport layer service model and the client to server parallels and peer-to-peer parallels. And also we will learn some protocol about the example for the popular application layer protocol, the infrastructure about the HTTP, SMTP, for the email, IMAP of the protocol, and somehow it's about the domain name service, and the video streaming system, CDNS, video streaming system, and the programming the network application, the circuit API interface. So some network application is social networking and web, and also the texting message, and also email, and multi-user network games, and the streaming, like a store video, YouTube, and the Hulu, and the Netflix, and also P2P file sharing. And somehow maybe the Skype, the voice over IP, and the real-time the video conference like room, and the internet search, and the remote login, blah, blah, blah. And we create the network application like this one, right? A mobile, and also the computer, home computer here. For example, it's the mobile, and write the programming like a long time different end-to-end service system. Communication over the network, like the mobile access to the base station, and the base station over the router. Goes through from the router, and router go to the national or global ISP, and the ISP interworking to the other local or regional ISP or the other content provider network or the data center network, and to link to the other enterprise network, or to link to the other content server, which means this network. So the web service software is communication with the browser software, right? So for example, is mobile to the other enterprise network and or server. It can see the application layer and the transport network data link physical layer to the application to the other application. So we transfer from this two-way communication, the two transport application layer, to here, to server, to the other enterprise client over this computer over application layer protocol. So it's actually no need to write software for the network code device. Network code device do not run the user application. The application on the end service allow the rapidly application development communication. Okay. So application based on the end-to-end system service. So you can see the client to serve the parallel behavior. You can see this one. The server always on the host, right? And the permanent IP address is permanent. For mobile phone, it should be the dynamic IP, but for the server, it should be the permanent IP address. And very often used in the data center or for the scaling. On the client, actually is communication with server, and maybe the intermediate is connected. So the maybe use a dynamic IP address because from the mobile you can go anywhere, anytime to access. That's why we have to use the dynamic IP address, and they do not communication directly to each other, right? For example, like HTTP or IMAP or FTP. So if we use a mobile phone travel a peer-to-peer architecture in the car, maybe the roaming or the connected to this computer or to this computer or this computer, the mobile to this enterprise network. It's not always on server, right? Right now it's a peer-to-peer architecture is not always on server, and it's a arbitrarily end the system direct communication, right? And the peer request service from the other peer provide a service in return to the other, and it's just a peer request service from the other peer. So it's no return and provide service to the other. So it's a self-scalability. New peer bring the new service capacity, as well as the new service demand. Right? Each peer are the intermediary connecting and change IP address. So it's very complex management. It's very complex management. So for example, like P2P file sharing, right? It's P2P file sharing. So processing communication, we process the programming running with the host. Within the subhost, the true communication with the inter-process communication defined by OS. So processing in different hosts, communication by exchanging message. So you can see it's a client-server system architecture. Actually, the client processing like the initial communication, and the server process that wait to be content. So you can see the node application with the P2P architecture have a client processing and the server processing. It's a processing communication and the P2P architecture. We have to client and the server process exchange the message, the communication, processing communication. For example, you can see the socket, right? The socket process send and receive message is true from to its socket. So the socket is application the process here, right? It's controlled by application developer, socket. And it's the internet, POP3 internet. We control by the OS is from the transport layer to the physical layer. The OS is control the transport layer and the network layer and the link layer and the physical layer. So different OS is different controlled by the different OS. And here is application processing the socket. So socket analog to the door, sending the processing shove the message to outdoor. So sending process rely on the transport infrastructure. On the other side, of the door to deliver message to the socket and receiving the process, right? They send the message to the socket to the receiving process. So two sockets involved, one on each side of the two sockets. So we need to addressing the process. To receive the message processing must be identifier. So host device has unique the 32-bit IP address. We call the Q definition, thus IP address of the host under which processing run the service for the identifying the process. So A replies answer. No, many processing can be running on the same host. So identifier include both IP address and port number association process on the host. Because of different application, the different addressing process and the identifier, both IP address and port number is significantly the port number association with the process on the host. For example, it's very important. It's an example of port number. HTTP server is 80. It's fixed to 80. HTTP server 80. And the mail server is 25. To send the HTTP message to the, for example, like to the galia.cs.umss.edu web server, the IP address is here, right? But the port number is fixed 80. HTTP server here. So most shortly, the application layer protocol defines type of message exchange, like request and response. So the message syntax, what field in message and how field are denied. Message the semantics, the meaning of information in this field, which each field we have the different definition, different of the what can we fill in this information. And the number is for when and how the processing sent to response to the message. Open the protocol, define the INC. Everybody has access in the protocol definition. Allow for the interoperabilities like the HTTP and the SMTP for this open protocol. So the properties protocol like a proprietary protocol like Skype and the root. So what the transport service does the app need, like the data integrity. Some apps like file transfer and web transfer transaction require 100% reliable data server, right? Data transfer, because the data integrity is very important, right? Because if we receive an email, we need to understand that there's no any change, and the data need to be integrity. And the other apps like audio, the torrent some nodes, because in real time, if we don't stop packing, we don't care. So timing is some app like internet and telephonia and the interactive games require low delay to be very effective. Example like very real time interactive games like the shooting game, right? You need to very real time to detect the enemy and the shooting very quick. And about the throughput, some application like a multimedia require minimal amount of the throughput to be effective. Some apps like Elastic app make sure and make use of whatever the throughput of they get. So security are related to the encryption and the data integrity. So transport service requirements common app like application layer, you can see, for example, in this table, the file transfer download, no loss, right? And email, we don't need any loss, right? And web document, no loss. And real-time audio, and all video, we can have some tolerance loss. And streaming and the audio video, we also can accept some loss tolerance, right? Loss tolerance. And the internet, some maybe not loss tolerant. And the testing the message, no loss. And the throughput, somehow throughput is less tape here from the email or the web or the file download. We don't need care of the throughput, so it's just elastic. And it's not time sensitive, so it's no time sensitive. And if we call the video and the audio call, and we cannot accept delay too much, right? So it should be the time sensitive within the 10 millisecond. And the audio sometimes we can accept by our ear is maybe 5 kbit per second to 1 megabit per second. And the video sometimes we want the quality is 10 kbit per second to the 5 megabit per second. So the streaming is a center of speed above. Okay, the streaming definition. We watch the TV on the streaming audio and the video is the same definition. So audio is 5K to the 1 megabit per second. So basically the video is less than the 5 megabit per second, we can accept. And somehow it's very time sensitive, it's a few seconds, okay. And somehow it's interactive games. We need to consider throughput, maybe the kbit per second plus, as quick as possible. So maybe it's somehow it's maybe time sensitive. And somehow it's a testing message. We don't care the throughput elastic, so it's just maybe time sensitive or not. But basically, we don't need any data loss about the testing message. So you can see different services and different reliable data. And in the Internet Transport Protocol, the service, we can define two kinds of services, TCP and the UDP. Actually, the TCP is a reliable transport layer between the sending and the receiving process. So we can see the TCP is on this service. The for control, the buffer, we need to consider buffer on the TCP. So sender won't overwhelm the receiver. And also on the TCP, we have the congestion control. The throttle the center when the network overloading. And connection oriented, we have to set up the required between the client to server process in TCP service. Also, we don't want to provide timing and the minimum throughput guarantee and security. So we still provide the timing, right? Because TCP is reliable, we have to make sure all the packets to be received and the minimum throughput guarantee. We don't want to the minimum throughput guarantee and the security. But the UDP, is unreliable data transfer. So between the sending and receiving process. So actually, UDP does not provide reliability, right? It's the opposite to the TCP. We don't provide the TCP reliability, and also we don't want to provide for control, congestion control, timing, throughput, guarantee anything, security, connection, setup, whatever, anywhere, about any reliable data transfer. So we don't care anything in UDP. We just back and forth to send. So question is why bother or why this layer in UDP? Okay, So Internet application, the transport protocols, you can see in this table. For example, application layer here. The application, based on the application protocol, is related to the transport protocol. So file transfer, download, email, web document is the same as TCP, right? Because it's a reliable protocol. File transfer, download, email, web document. We check this data we want to correct, so it's a reliable protocol, TCP. But the application layer in protocol FTP, right? File transfer, we use SMTP, and email is SMTP or RFC 5321. And web browser is HTTP 5.1. Yes, is all the transport layer TCP. And the Internet telephone link, somehow is we want to guarantee the VoIP service, VoIP quality, we can use the TCP. But somehow real time, and most of time we use the UDP because we don't care any the protocol, the quality in the telephone over the IP network, right? So we use a UDP proprietary the protocol, maybe the SIP or RTP or the proprietary. And the streaming audio video, somehow we need to care of the quality. So maybe the HTTP, the RFC 7320 and the dash in TCP. So interactive gain is based on the real time or not real time. So if we consider the reliable data is very important in TCP, but if somehow we need it as quick as possible, maybe the UDP. So it depends on the WOWO, the FPS proprietary protocol in application layer protocol. So in this table, you can see very clearly the Internet application, the transport protocol in the UDP or TCP. The TCP, we call this definition is reliable, but UDP is unreliable. So how can we secure the TCP? It's a vanilla TCP and UDP socket. So based on this TCP vanilla and the vanilla UDP, the socket is no encryption, and there is a clear text password sent to the socket, transfers the internet in the clear text. So the transport layer security we call the TLS, transport layer security. So provide the encryption TCP connected end-to-end encrypted TCP connection. And also we have to do the data integrity and the end-to-point authentication. So TSL implemented in application layer. The application uses the TSL, the transport layer security, the library, like using the TCP in turns. Clear text sent to the socket, and the transport internet encrypted. So the web and the HTTP first, we can quickly review. The web page consider object, and each of which can be stored on the different web service. So object can be the HTML file, and maybe the JPEG file, and the Java API audio file. So you can see the web page considered based on the HTML file that includes several reference objects, each addressable by URL. For example, like the home name right here. You can see the www.com, someschool.com, and edu, and then somehow it's a page name. In the somehow is maybe the GIF file. So it's host name and the page name and the file. We call the URL in each address by URL. Several reference objects on the basis of the HTML file. So HTML overview actually is a Hypertext Transfer Protocol. On the web service, web application layer protocol, and the client server model. So client is browser like request receiver using the HTTP protocol and display the web browser and web object. And on the other hand is the server. It's a web service sent to using the HTTP protocol, the object in response to request. So we can see in this scenario, the PC running the file browser here, right? Then we call the HTTP request to the server running Apache web server and response to the HTTP to the web PC computer, PC running the web browser, and the server response to the HTTP response from the HTTP request from the client. And the mobile also can do some this server browser. The HTTP request to the server and the response from the server to the mobile on the HTTP response to this mobile. So basically, the overview, the HTTP use the over the TCP, which means the HTTP consider reliable data, and the client the initial TCP connection create a socket to the server, the port defined to the 80. HTTP we saw this definition, the HTTP so the port. If we using the a browser, the port should be the 80. So server can accept the TCP connection from the client. TCP connection, then HTTP message, the application layer to the protocol message is changed between the browser and the web server on the client and the server. Follow the HTTP browser and follow the HTTP protocol to the client to the server, and the HTTP connecting host. So it's a build up the connection of the HTTP and build up the TCP connection, and make a connection and make a connection host. So client initial the connection, and the client then the next step of the connection host. So HTTP is used the status. The server maintains no information about the past client request. Fine. So aside, you can see the protocol that maintain the state are very, very complex. The past history, the state must be maintained. If the server and the client crash, their views of the state may be the inconsistent, may be called silent. So how can we do? In HTTP connection, two types. No persistent HTTP and persistent HTTP, right? We can have two connection type over the HTTP. One is no persistent, the other is persistent. So the non-persistent, first one is TCP connected open. And the second is at most one object sent to over TCP connection. The third is TCP connection closed. So we downloading the multiple object require multiple connection based on the unpersistent HTTP. The other is persistent HTTP. The TCP connection open to the server. And the second is multiple object can be sent over single TCP connection between the client and live server. So TCP connection can be closed. Okay. So overall, we can see the TCP over the HTTP, and here is non-persistent HTTP and persistent HTTP. Okay.